So in the previous lecture we talked about the different coastal landforms, and I hope by now you must have been comfortable in looking at like several cartoons or the sketches which shows that how the different erosional and depositional landforms will look like along the coastline. And as I told that the different landforms will depend on, or the typical landforms will depend on the how the coastal configuration is, okay, and what is the longshore wave direction and all that, okay. So you may see the bay areas, you may see the beaches, okay, and then headlands, okay, Tambalu and all that, okay. So and then of course the marine terraces also. Now this is a typical example of what we were talking about, the spit, okay, and spit is highly dependent on the direction of the longshore waves, okay. How it looks like from the space, okay, and this looks like something very typical. So you have a barrier which has been getting slowly developed, okay, or building up, okay. Will come, this will completely get closed and this will become a sort of a lagoon area, okay. So this is a typical of spit. In another example of the spit at the fringe of the reef, okay. And then coming to the beaches, how it looks like, okay. This is a typical example of beach as well as the rocky cliffs, okay. You are having the cliffs along this from Andaman. Now coming to the lagoon, enclosed and protected by barrier beaches, okay. Water river draining into them and develop into sort of an wetland or marshy areas, okay. So this is slightly away from the beach, okay, fine. So you have an marshy area or a marsh or a wetland which has started developing in this area. You will have a contribution of the line water or the ocean water at the time of the high tide, okay. And if you see this side here where my pointer is, this is slightly in higher ground, okay. And if you cross this, okay, you will go down towards the ocean, crossing the beach, okay. So what if I have to draw a section here, then what it looks like, okay. So you have a beach here, you go up here, and then you are having the shallow area. So this is your lagoon and this one is your beach ridge or the longitudinal dune, and then you are having the beach, and then you get into the ocean here. So this is a typical topography which is seen in some of the location along the coastal regions, okay. So you will have again the mangroves which are typical most of the coastal regions, okay. How it looks like, the tropical mangroves. Now beach ridges, shallow lagoon, or we can say the wetlands, and then tidal flats, okay. As I told that if you have a spit which is developing, maybe the time will come this will close up and then you will have a formation of the pond or the enclosed lagoonal area or a bay area, okay. This is an interesting thing which you can use as an typical of photo interpretation. Now this story comes from in the 2004 Sumatra Andaman earthquake, okay. So this is a Landsat data of Trinkat Island. Of course it's covered with a lot of clouds here, but just to show that what exactly happened. But this is before the 2004, and then one of the photographs which I was showing was from here, the terraces from Andaman, okay, that is Kamarota, and we'll see some examples of the photographs from the Trinkat Island, what happened during 2004 Sumatra Andaman earthquake, again using the satellite data, okay, or we can say This is first, which I already explained this, but I'll talk. This is from this area, this one. This is a KANPUR-NPTEL Island. So what you see in the next photograph, the photograph which we have taken is from this direction. Okay, so you can see this portion and that. Okay, so we have like as I told that we were able to pick up multiple terraces here, which also indicate the previous sea level. Okay, so we have also drowned shorelines along the KANPUR-NPTEL Island, and this is a photograph which is taken from this side here. If we go further this side, then we took from here, like looking like that. Okay, clearly you can make out the drowned shorelines. Okay, and if you draw this, you can see this here. Okay, so there are channels here, small channels. Okay, and this is a present shoreline here, but again this portion, if you clearly see, there is a clear difference over here. Okay, so this portion, and then you have a channel which is similar to this what you have. Okay, so the ancient channel here. So this is your drowned shoreline, and this is the area as I was talking about, that this have a different shade. Okay, this got subsided or submerged after 2004 earthquake. Okay, so this is an example of the drowned shoreline as well as the submerged area after I will remove this so that you can clearly see it or differentiate at least. Okay, you try to see this portion here, and then you will be able to make out the drowned area. Okay, even this is submerged. Okay, now splitting of island, that is in Trinkat Island. So this is before 2004, and if you see the date, it is I'll request TA to make it correct. Okay, look, correct to see properly. It says 21 December 2004. Okay, and what happened in 2004 December 26th? Okay, you can easily make out the difference. Okay, so you see this portion here comparatively what you see here. Okay, fine, that is a variation or the difference. This was because of the land level change which took place. The area subsided. Okay, and the island is not having that much of elevation to protect the movement of the waves. Okay, or the ocean waters. Okay, so ocean water crossed the island here, resulted into the inundation of this part. So what you see is the splitting of two islands. Now this is one island, this is another island. Now water flows through and through. Earlier it was not. Okay, because the area went down, subsided, you are able to see this. Okay, so you can compare this and see what happened during that. So again, and a way to use the satellite data. Okay, now this is aerial photographs, oblique aerial photograph which you took. Shadow here you see is the blades of the airplane engine, and this is what they say, the splitting of the island. Okay, this portion which I have shown here is seen here. Okay, so earlier it was, the landmass was exposed here, but because of the subsidence, it has, the water has flown through and through this, giving an impression that this island has been splitted in two. Okay, fine. Of course, in some areas there was an erosion because of the tsunami waves. So tsunami impact, again another satellite photo which shows that the difference between the before and after. Okay, same area. So the idea here is to show you this, that you can easily make out that how much portion was affected by the tsunami waves. Okay. So there is the same island over here, but now you cannot see the same existing. Okay. Even if you can see, it is very clear the bridge has been blown off from here. Okay, and most of this portion here is gone. Okay, and over here also in this area, maybe you can see this, only this portion here, and then most of the area. I'm just doing very rough this thing. Okay, this whole area has been affected. Okay, so you can easily make out that how much area got affected and how much land we lost. Okay, during the 2004. Okay, this is another example from Sentinel Island, but this shows the emergence. Okay, or the area got uplifted. And the Sentinel Islands exist on the along the west coast of Andaman Islands. Okay. Similarly, like this also you can make out easily that how much area was affected from different images. Okay, so comparison of different images also helps you in typical of land use pattern. Okay. Another example, before and after. So this is an after one. Okay, where you have this again. This is an Interview Island and North Reef Island, which shows the emergence of the area. Okay, so next photograph from this area will show you. This is before, okay, and this is after. Okay, so this is an Interview Island, which shows the uplift of the coral reef, and this is an Interview Island which also shows the uplift of the coral reefs. Okay, so the area uplifted and the coral reef exposed to the surface. Okay, so you can see a large number of micro atolls here which are sitting above the mean sea level. Coming to this, these are few photographs, aerial photographs, from which we will try to tell you that how you can extract the landforms. Okay, so the different type of fluvial landforms we already discussed in the previous part, but in this we will show you that how quickly you can identify and extract the information of different landforms. Okay, and that also helps you in locating the sites for if you are coming up with an future development. Okay, I'll do this and then we will stop here, but this is the one. Okay, now if you look at this one, this photograph, what best you can trace out is the most prominent features. Okay, so you have an outline here. Now this, of course, we can easily make out and say that this is the present day channel, and in between we have some channel bars. Okay, so this is the present part of the channel. Of course, this all bars are the part of active floodplain. And then here, if you carefully see this portion, okay, is your cliff. This is your river bank. Okay. Similarly, on this side also, you can see this. Okay. So this portion becomes your terrace, as well as here also. Okay. Now, the other part which you will talk about will be the shape or the morphology of the channel. So you have a meander here, you have a meander here. Okay. So this portion will be more erosive, this portion will be erosive, and this portion will be in the deposition areas. Okay. So this you can easily mark. Okay, fine. As well as other than that, you can demarcate again these are the channels, okay, which are coming and meeting this one. Okay. There are the streams which are coming and meeting the main stream here. Okay. So these are the hilly areas which you can mark. Okay. Now coming to the next photograph, again these are very similar but black and white photos where you can pick up the fluvial landforms. Now one thing very important here, we can ask while tracing out the landforms here, okay, that why the channel is so straight here. Okay. And then you have a very thin portion of vegetation here. Okay. Now this channel here, what we say is your channel is an example of a channelized flow. Okay. So artificially constructed levees on either side to allow the water to flow through and through here. Other than that, another important feature which you may be able to pick up, but it will be easier if we see this in 3 dimension. Okay. So there is a fault which runs here. Okay. A very active fault, okay, along this line here. Anyways, this is another part for that, but this one is a typical of a channelized flow, where we can see the levees on either side, which are protecting this area during the peak flood. Okay. So water will not spill over. Now if you have to draw the cross section, how it looks like, okay, here the cross section will be something like this. Okay. You have a channel here and then you have an area. So these are the areas which you want to protect actually. Example, if you see here, okay, is again very typical of your channel here, and then along with that you have a settlement sitting on this region. Okay. So if you carefully observe, then you are having you can identify some man-made structures. This is a bridge here and bridge, but at the same time, if you see the portion on other, like the accumulation of the water on both the sides, okay, probably could be an barrier here. Okay, fine. But here, this portion you see, and this contact here is your river bank. Okay, so this becomes terrace. And again, if you see this one, you are having a meander. So this portion is getting eroded, and this portion is not getting so much affected. Okay, fine. Another example of the channel morphology, where you can easily pick up the sandbars and the meander bars here also. Okay. So we'll give you some exercises, okay, which will help you in identifying and delineating such features, okay. Now this is a cliff here. It goes like that, okay. So this is one surface, and same surface of at the same height, okay, is also seen on the other bank. So this is also the same, and this portion is the base of the hills, okay. So this is on surface. So this, if I say the T1 or T0, so this is also T0 surface, okay, here. So like that you can pick up several landforms, and this is in present a bar. It's part of the active floodplain. We will discuss in greater detail, like we haven't talked about the different type of Aeolian except Aeolian landform, except one slide and one area which I was talking in the for close to Gujarat, is along the border of India and Pakistan, that is Thar Desert, okay. Now getting into the landscape identification of Aeolian, or the developed by the wind action, we need to learn a little bit about that, how it looks like, okay, like different dunes, how it looks like. Either they are the barkhans, or we say transverse dunes, or we say longitudinal or linear dunes, parabolic dunes, star dunes, okay. So what does type of features we will see on the surface, okay, about the, because we have, and typical of like what you see here, okay, the wind directions are been shown here, okay, fine. But then also we are having different type of related to the wind action, okay. So which side is your, this is a windward side, and this is a leeward side, okay. And then you are having Barkhan dunes, again you are having the wind direction from here, but then you are having the leeward side on that, okay, fine. So based on the shape and all that, we will try to get into the details of this one, and then we will try to see that how it looks like on the surface of the earth from the satellite data, okay. So we'll stop here and we'll continue in the next lecture, okay. Thank you so much.